Hi guys, welcome back to Math 135. Today we're doing section 2.5 about polynomial and rational inequalities. And this is the third to last section from chapter 2. You notice chapter 2 is a little shorter than chapter 1, at least the sections we're covering. And we've got this one, 2.5, then 2.6 and 2.7, and then that's it for chapter 2. Then after that we'll have our review and then exam. Okay, number one thing that we're learning today, how to solve polynomial inequalities, which makes sense because that was one of the topics of the section, right? And the other thing is how to solve rational inequalities. That's the other thing of the section. So those two things. And what makes it an inequality? Inequality just means that you have either a less than or less than equal to sign, or a greater than or greater than equal to sign, instead of an equation, right? So instead of having an equal sign. With an equal sign, it's an equation. With an greater than or less than equal to greater than equal to sign, becomes an inequality. Okay, you notice today's notes actually fit on one page. Hallelujah! But that's because there's not a whole lot of theory to talk about today. Just two things, how to solve those different inequalities. Now let's start with number one, solving polynomial inequalities, for the third time on the same page. To solve a polynomial inequality analytically just means without actually having to graph the thing physically, then what we do is first set one side equal to 0, and then we solve for the zeros. And we've done that before with polynomials. Remember finding the zeros or x-intercepts of the polynomial, right? So find the zeros, and then what you do is you check test values. So in other words, you plug in values that are to the left or right of those zeros to determine whether you're above or below. And if you think about your inequality is compared to 0. If it's either going to be greater than or equal to 0 or less than or equal to 0, so those test values are going to tell you, are you above 0 or below 0? Okay, the second way that we can solve a polynomial inequality is by doing it graphically, which means just graph the thing and just look where is it above the x-axis and where is it below the x-axis. And since you're comparing to 0, where it's above, it's going to be where it's greater than or equal to. Where it's below, it's going to be less than or equal to. That equal comes into play if you include the x-axis itself, if you include the point where it is exactly 0. And, solving rational inequalities, I'll kind of just cut to the chase here. It's going to be pretty much the same thing. We're going to almost do exactly the same directions. If you look at the explanation here, this whole part is all exactly the same. And then the next line, there's just one additional little caveat here, which is not only for the zeros, but also check the restrictions. And restrictions, remember, with rational inequalities or rational functions, you've got restrictions because you're dividing by things. And when you divide by 0, that creates a restriction, right? So that's the other thing to watch out for, where the denominator is 0. And then after that, you do the same thing. You test checkpoints around the zeros and also the restrictions. And then you use that to determine solution intervals. So almost the same directions, right? And then for the second way to do it graphically, well, same thing, right? You just graph the rational expression, which we've practiced before in a previous section. And then you look, okay, where is it above or where is it below the x-axis? And above and below, that tells you where you're either greater than 0 or less than 0. Okay, one thing to be cautious of when you're dealing with rational inequalities is you don't only check the zeros, but you also have to be aware of the discontinuities and any vertical asymptotes, especially the vertical asymptotes. Discontinuities aren't typically, they're a little bit of an issue because you have to exclude a single point there, but the big one will be vertical asymptotes. Actually, they're pretty much, if I think about it, they're pretty much equal in terms of priority because you got to check both either way. Okay, but that's it for the theory, guys. So the rest of the video and the next videos is just going to be working on the problems. And there's just two types of problems, solving polynomial inequalities and then solving rational inequalities. So in this first video, since we spent a few minutes discussing the theory up front, we'll probably do a few less questions in the rest of the videos. So I'm thinking maybe the first 3 questions to start. So let me just lasso these guys. And then bring them down here. Let's work on them. Okay, the directions say to do it with the test point method and graphical method. We'll see how things go. I'm not sure we'll do every one both ways, but we'll at least see both methods at some point. Okay, number one is the easy one. So let's start with both methods for this one. That'll be pretty fast. if you look at this expression, x plus 4, x minus 6, less than or equal to 0, it's already set up for us where it's one side of our inequality is 0 already, right? And so we're going to go straight to our test points. And when I make test points, what I'm going to do is just kind of imagine these things on a number line. What are the zeros here? The things that would make this equation 0 would be x equal to negative 4, right? Because then this part would become 0, or x equal to positive 6. So I'm going to plot those 2 points on my little number line here. Negative 4, here 0 is somewhere in the middle if you want to write that down. You don't have to. And somewhere positive here is positive 6, right? Okay, so using analytical methods, that means I'm going to plug in points and see what pops out. There's 2 ways you can plug in points. You can either just plug it into your original function, or you could use the synthetic division, right? Remember, Saul, that the remainder is equal to the function evaluated at that point. So that's a little cool trick. But personally, my personal preference is just for a question like this, plug in a point. So I'm going to pick something immediately to the left of negative 4. I can pick anything in between negative 4 and positive 6. I'm going to pick 0 because that's an easy point to work with usually. And then something immediately to the right of 6, I'll just pick 7. Okay, so those are my test points. And all I care about is if it's positive or negative. I don't technically even have to figure out the exact value. I just need to know if it's positive or negative. So let's look at negative 5 here. If I plug in negative 5 over here, negative 5 is less, I'm sorry, negative 5 is, it's more powerful than the 4, right? So that's going to turn this part negative. If I put negative 5 here, negative 5 minus 6, that's also going to be negative. So overall, that tells me to the left, negative times a negative is a positive. Okay, so that's first position. Let's use a different color for the next one. Okay, so now I'm going to go into 0. If I plug in 0 here, 0 plus 4, that's going to be something that's positive, right? If I plug in 0 here, 0 minus 6, that's something negative. So I've got overall something negative. Okay, so negative in between. And then what about, let's pick another color. Where do I put it? Take over the blue. Actually, we'll just stick with blue. Okay, so next we're going to check 7 here. 7 is to the right of 6. If I plug in 7 here, that's going to be 7 plus 4, that's positive. 7 minus 6, positive as well. So positive times positive is going to be positive. Now, if you prefer, you can actually plug in the exact number and figure out what you get. Like you can actually plug in 7 and calculate that. It'll be 7 plus 4, which is 11, and then 7 minus 6, which is 1. So 11 times 1 is going to be positive 11, and then you can figure out positive and negative that way. But to me, I'm lazy, so I just want to make sure I know, whether I'm positive or negative. That's enough information for me. Okay, now coming back to the original inequality. So look at this original inequality, and I want to know when it's less than or equal to 0, right? So since it's got that little line underneath equal to 0, that means it includes these points where it is exactly 0. So it includes negative 4, includes 6, and otherwise I want where it's less than 0. So that would be this part where it's marked less than, right? Negative. That means this is the interval I'm looking for right here. Plus, so this interval that I just am highlighting, plus those 2 endpoints, which now I'm ready to answer my question. Here's the answer. Oh, I spelled answer wrong. Answer. From negative 4 up through positive 6. Notice I have hard brackets because I'm including the endpoints. Yeah, so final answer here in yellow. Actually, let's do orange because here that'll kind of match the graphical version I have above the number line. Yeah. Okay, let's say I wanted to do this graphically. Well, we have some tricks to graph something like this, right? We know the multiplicity of roots. Guys, remember that? Multiplicity of roots? Remember, if it's odd multiplicity, it goes right through the root. If it's even, then it just bounces off and touches it, kisses it. So here's my xy axis. I've got negative 4 as one root, or 1, 0. I've got positive 6, 1, 2, 3, 4, 5, 6. And I can check the end behavior. If I'm something way off to the left, that's going to be negative, and negative, that's going to be positive. So I know I'm going to be up here, right? And I know I'm going to pass through that root, and then I'm going to pass through that one because they're both odd multiplicities. So my graph's like very basically something like that. Of course, it's not an accurate shape, but I do know in terms of above and below the axis, then that should be correct, right? So now I come look at this thing. Okay, where is this thing less than or equal to 0? What's less than 0 in this region right here, right? And it's exactly equal to 0 at those endpoints. So notice that matches exactly what my answer was when I did it analytically, right? Here, this is -4. Oops. Here, this is -4, and here, this is +6. So again, that matches the answer here. All right, number 1 down, and we did number 1 in actually 2 ways, right? We did it the analytical way, and then we confirmed it with the graphical method. Now, I'm not requiring you guys to do both methods for every question. You can actually pick, but at least do a few of both types, just to make sure you have enough practice. And if you want extra practice, it's a good idea just to do both, especially for these easy ones. Okay, number 2. Let me just copy this thing down. X plus 2. Oh, you know, let's do it graphically first this time, and then we'll go back and confirm analytically. Okay, so I'm going to start with the graphical method. Here I have my zeros, right? Let me just write them down. X equal to 0 would be a 0. -2, that would make this 0, right? +3, +9. Let's go straight to graphing. Here's my x-axis. Here's my y-axis. There you go. And I'm gonna go, what is my smallest one? Oh, I can't see that negative. This was supposed to be a -2. I think I said -2, but I can't see my negative sign there. Okay, it's -2. -2 is my smallest one, right? So out here, 1, 2. And then I've got 0 as another root. I've got 1, 2, 3 as another root. And then 4, 5, 6, 7, 8, 9. So those are my roots, my zeros. The only one that has even multiplicity is the 0. So that's the only time it's going to kiss. Otherwise, it's going to go straight through. Now, let's look at left end behavior. If I put a negative infinity, what happens? Something going towards negative infinity. This is going to be something really big and positive. Negative. Let me write this on. Positive, right? Because it's squared. Negative, negative, and negative. So overall, it looks like 3 negatives makes a negative overall. So looking at left end behavior, my graph should be negative on the left. Now, first root crosses through because it's odd. And then this one should just kiss because it's even. And then come back down to go through that 0. Ooh, it missed. Try that again. Kiss that one. Come straight through that one. And then straight through that last one. Let's double check our right end behavior. This is positive, 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 positive. So yeah, it makes sense that our right end behavior goes upwards. Okay, now, easy, yeah? From here, just gonna highlight the spots that are less than 0. So less than 0, it looks like only this one region right here. Notice this time, because it is strictly less than, that means I'm not gonna include these points right here. So I should have the soft brackets. What do you call those things? The soft brackets. Okay, here's the answer. So answer is from this position, which is 3, up until 9, right? Oh, I'm sorry, guys. I'm sorry. What am I thinking? There's another area that's below, which is this region, yeah? Sorry, sorry to excite you about potential extra credit, guys. Okay, so that's not including this point either, right? Okay, so let's start from there. The leftmost part, that's negative infinity, all the way up until that is -2, right? So up until -2, but you don't include -2. And negative, anytime you have infinity, it always goes with a soft bracket. So that is one portion, and also from 3 up through 9. Again, soft brackets here because we're not including the 3 or the 9. Okay, let's just check real quick, kind of same thing, but analytically here. So let's say I don't actually graph the thing, but I am going to plot these values on a number line. Let's use black for the number line. Okay, and then just plot my zeros, which were -2, 0, 3, and then 9, right? So I want to check test points. I got a bunch of test points this time. I'm going to pick -3, -1, because that's between 0 and -2. Here, +1, let's pick 4, and then let's pick 10. So I got 5 to check, yeah? So if I plug in -3, -3 is going to make this guy here positive because it's squared. That's going to be negative. -3 minus 3 is negative. -3 minus 9 is negative. So overall, we're looking at negative over here, yeah? Yeah, let's just do everything in purple. Okay, if I plug in -1, so let's redo this check here. This is going to be positive because it's squared. -1 plus 2 is positive. -1 minus 3 is negative. -1 minus 9 is negative. So negative times positive times positive. Overall, it's positive. And we're right now, if you look, you can compare it to our graph, and it's so far confirming what we already know, right? Okay, next I'm going to plug in 1. If I plug in 1, this is positive. 1 plus 2 positive. 1 minus 3 negative. 1 minus 9 negative. So that's all together going to be still positive. Okay, and then what about if I plug in 4? If I plug in 4, this is positive. 4 plus 2 positive. 4 minus 3 positive. 4 minus 9 negative. So this is negative in that area. Yeah. And, you know, what's happening here, just think about it with me for a second. When I plug in a value, because I know these are the only zeros, like in order for it to change signs, it's got to pass through, it's got to touch a 0 at least, right? So these are the only possible sign changes. That's why it's enough to only check a single point with between those regions. And if it's positive or negative, I know it's got to stay that until it hits the next position, and then it could potentially switch. But like you saw right here, it didn't switch. It doesn't always switch, right? And we know it's not because it says multiplicity that's even. Okay, last checkpoint is 10. This will be positive. This will be positive, 10 plus 2, 10 minus 3 positive, 10 minus 9 positive. So it's all positive, which means overall that's positive. So looking at it now, which are the negative regions from here? -3, -2 onwards to the left. And then from 3 to 9, right? But once again, we're not including these points because we're looking for strictly less than 0. Okay, so that's number 2. We did it both ways again. And now, you know, we've done 2 questions in both methods. So for the next one, let's just do it one way. Okay, we've kind of seen how they go. And from now on, I think I'll just pick one or the other to do. Make sure you're able to do both, just in case, you know, you're asked to do it one specific method or the other. Okay, number 3. Just copy this thing down. Okay, I noticed they're all odd. They're all odd multiplicities. So that's kind of good news. It makes it simple. It just means that it's always going to cross through. There's not going to be any kisses. Okay, what are the zeros? X to the third means if it's x equal to 0, that would make it 0. Here, x equal to -8 would make that 0. X equal to -11 would make that 0. X equal to +4 would make that 0. Okay, so I said I was going to do the graphical method, right? Is that what I said? Or did I not say? Okay, I'm going to do graphical. Okay, so here's the x-axis. Here's the y-axis. Oops. Okay, and let's plot our zeros, starting with -11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So here's the 0. And -1, 2, 3, 4, 5, 6, 7, 8. -8 is right there. I went 0 and +4. 1, 2, 3, 4. Okay, notice they're all odd multiplicities like I mentioned, right? This is a 3, this is a 3, this is a hidden 1 for both of those. So it's going to pass through each time. What's the left end behavior? Okay, if I plug in negative, something that's really big, x to the third is going to be negative, right? Like think about -1,000 to the third power is -1 with 1, 2, 3, 4, 5, 6, 7, 8, 9 zeros, which is 1,000,000. No, that's not right. Never mind. It's not important. It's negative. Okay, then negative big number here would be a negative to the third power, still negative. So that's going to be negative. Negative big number plus 11, also negative. Negative big number minus 4, also negative. So all 4 of these factors are going to be negative, right? Negative, 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 negative. That's 4. Altogether, that makes it positive. So left end behavior is looking like it's going to be positive. Now, this is a single third odd multiplicity, so it's going to pass through, hit the next 0, pass through, hit the next zero, pass through, and then hit the last zero and pass through. So every time it passes through. Now, does that match up with our expected end behavior on the right? And the answer is yes, because if you put a really large positive number, positive, 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 everything is positive. And you're multiplying them together. So yeah, it should go positive. Okay, now answering the question, where am I above the x-axis? Here it's positive, right? Here in that in-between region, and then here onward forever. So those are my intervals where I am greater than 0. And here I am not including the boundary points again because of that strict inequality, right? So do not include these points. That means my answer is as follows. First, negative infinity always remember goes with the soft bracket. And then stop at negative 11, again soft bracket. Union with that middle region from negative 8 to 0. That's 0 right there, right? That's 4, by the way. And then union with the region from 4 onwards. 4 onwards means from 4 to infinity. Just like that. Okay, that was an ugly box, so I'm going to erase it and let's just highlight the answer here. Okay, guys, hope that makes sense. As always, if you're having trouble, don't hesitate to reach out. And I'll see you in the next video.